Hej och välkomna till dagens webbinarium tillsammans med AIKO. Björn Nordin heter jag och är ansvarig för utbildningsavdelningen här på Synergia. Idag kommer vi gästas utav Mohammad Al-Sharuf från AIKO, där Mohammad är teknikansvarig. Och vi kommer få dyka ner i AIKOs nya paneler. Framförallt kommer vi kika på deras uppdaterad modell utav Neostar, så Neostar 2 Plus. Och också dyka ner i deras ABC-teknik på celler. För AIKO är ju både en celltillverkare och en paneltillverkare. Jag som har varit med här på webbinariet tycker att det är väldigt spännande och vi har många olika delar att kika på. Några höjdpunkter för min del är ju när vi går ner och pratar om den partial shading optimization som AIKO har. Så hoppas ni ser fram emot att se på det. Så dagens agenda, lite kortfattat, intro kring AIKO, om deras resa som företag. Vi kommer också kika på ABC-cellteknologin, så all back contact-teknologin som AIKO har utvecklat. Och sen sammansättningen av det då i form av Neostar 2 Plus-panelerna och också deras kommersiella större paneler. Där han får till en världsledande effektivitet på panelmodulerna. Avslutningsvis så kommer Mohammad att visa upp några olika one-pagers med fokus på hur kan man räkna ut lönsamheten av att använda en sån här modul versus en annan. Så väldigt spännande webbinarium att se på. Ifall ni är intresserade av mer utbildning kring antingen produkter såsom AIKO eller bara allmänt om solenergi så rekommenderar jag er att gå in och kika på senergia.se/utbildning. Och sen så har vi också otroligt mycket material här ute på YouTube. Och ni kommer hitta massor kring våra andra tillverkare, även allmänt om solenergi. Så hoppas ni njuter av dagens avsnitt och vi ses snart igen. Hej så länge.
Give you a small brief about myself. So my name is Mohammed Al Shroof. I joined AIKO last summer. I am working as a technical solution manager. I am based in Düsseldorf in Germany, but I will be coming to Sweden from now and then. I think also in May we will be having a 2 to 3 days van trip with our van. Might be visiting some of you guys to interact with you and also show you our products and provide you the technical support you need.
Yes, and when we are decided about this tour and the stops for it, we'll let you know in our newsletter. So I'll keep you updated on that.
Yeah, perfect. So who's AIKO? AIKO actually is one of the biggest solar companies in the solar industry, where AIKO managed to produce more than 120 gigawatt of solar cells, and with a revenue of 2022 more than $5 billion US. We are very technology-driven company. We do a lot of research and development. And this is our strength point. So we have 3 research and development bases, 2 in China and 1 in Germany in Freiburg. We have more than 17,000 employees. 20% of them are dedicated to work and research and development. And they delivered more than 1,000 patents in the solar industry. Production-wise, we have 5 production bases. All of them are located on the eastern part of China, which is far away from the conflict zone. And its annual cell production, it's 61 gigawatt, and the ABC module capacity is 25 gigawatt. So the journey of AIKO started in 2009, and even though I believe most of you started to hear about AIKO solar in the last 2 years. And the reason behind this, that since that time, the 2009 till 2022, what we call the P-type era, AIKO was focused on optimizing and manufacturing the solar cells. So we played a major role in industrializing different types of solar cells like tubular PERC, bifacial ones, as well as the G12, the big ones, the 210 millimeters. So we were leading the solar cell industry during that time. In 2021, we invented what we call the ABC cell. ABC stands for all back contact. So it's a cell based on the back contact technology, which has an efficiency of 26.5%. And in 2023, we delivered the ABC module with the most efficient module in the market with 24%. So this huge time we spent during the P-type era to develop the cells gave us the chance to come up with this new record in terms of efficiency in the solar industry. So basically, we do the complete manufacturing process in our factories from the cell till the final assembled modules. Also, we invested heavily in the mainstream products companies where we get the raw material we need to do the manufacturing, like the polysilicon and wafer. Yeah, we can call them like daughter companies. And this kind of investment gave us the chance to control the quality of these products to align with our standards. And also to trace these products. As you know, it's very essential topic nowadays, the ESG, to trace all our products in order to match with the market requirements. And also give us the chance to secure the supply of these products to match our manufacturing plans. So we don't have any issues. We have learned from COVID time regarding the supply chain issues, and we took that decision. We took this decision at that time to invest in those companies and control the supply of these material to our factories. Here you can see the physical presence of our team in Europe. So we have a distributed team in all regions. We are now around 85 employees. Our regional office is located in Germany, and our warehouse in Netherlands and Rotterdam. So in AIKO, we believe that it's very important to be very close to the customer and provide them a full service before and after sales. So we are not just doing like overseas sales. We are very close to interact with you and to try to fulfill all requirements you need. 2023, we got some awards and honors. So we got Red Dot Design, Intersolar One, and the ESG Transparency as well. Yeah, in this video, you can see our factory, which is located in Zhuhai. Zhuhai is located in the eastern part of China, very close to Hong Kong, just on the other side of the water. The annual production capacity of this factory is 15 gigawatts of solar modules. And we do there the complete manufacturing process, starting from the cell till the final modules. And as you can see, the factory is actually new in 2023 was launched. It's equipped with high-tech and fully automated production lines. Just a few employees are standing there. Basically, they are doing a physical inspection as part of the quality control process in our factory. So if you are going to visit China soon, please let us know. We can arrange a visit for you to see the factory from inside. This will be interesting for you. Yeah, in this part, I will be touching and talking about our products. So we designed our products to match different scenarios in the solar industry. So for the residential scenario, we promote what we call the New Star series. There we have 4 panels, all of them based on 54 cells modules, and they have all of them are less than 2 square meters. So we have the New Star 2S Plus. This is a dual glass, a full black module with a power up to 460. And also the New Star 2S. This is a full black monoglass with a power also up to 460. For the white back sheet, we have the New Star 2P. This is a monoglass white back sheet. It comes also with a black frame with a power up to 470 watts. And finally, the New Star 2N, this one has a typical silver frame. It's a monoglass also module with a power up to 470. For the C&I scenario, we promote two panels. We call them Comet series. So the Comet 2N Plus, this is a dual glass module with a power up to 625. And the other one, the Comet 2N, a monoglass white back sheet with a power up to 630. And finally, we promote the Stellar one. It's for the utility scale scenarios with a power up to 640. So this is also a dual glass bifacial module. Here you can see our unique selling features of our products. And our philosophy when we design our cells and our modules to let the customers to have the maximum power output in his property, like on his roof or in his land, if we're talking about the free landed projects, the ground mounted projects, and also generate the maximum energy out of each watt peak you install there. And by doing this, this will let the PV owner to achieve the maximum financial benefits out of the solar project. So we will be now going through these unique selling features one by one and give you more insight there. So higher power output. And the question is how we could achieve a higher power output. So what AIKO did, since our module is based on the back contact technology, where we managed to put all the metallization from the backside. I mean metallization like the fingers and bus bars, where the responsible electrodes, to pass the electrons and form the current in the circuit. So as you can see on the left side, we don't have any electrodes at the front side, and this will let our cell completely free to absorb the complete sunlight. On the traditional technology, normally you can see you still have some grid lines at the front side, and this will reflect part of the sun rays. And this gives us the chance to push the power output of our products. So for the New Star series, you can get more than 30 watts compared to the TOPCon module. Actually, we compare our modules with the TOPCon, not with PERC, because we believe the mainstream will be, in the coming years, will be TOPCon. And for the big modules, the 72 cells modules, the Comet and Stellar, you can get more than 50 watts compared to the industrial average, which is the TOPCon one. So by using normally our modules, you can either achieve the same DC output, the same power output with less panels, or you can you can achieve higher power output by providing the same number of panels of other technologies. Here you can see the most efficient module in the market. This list is published by Tying News. Tying News is a main player in the social media and marketing when it comes to the solar industry. And actually, we are sitting in this position for the last 18 months. You can see here the different technologies in this column, and maybe we need to focus on the last column, which shows the efficiency of the products. So the difference between our product and the second one is 0.8%. And if we keep an eye to see the difference between the second one and the last one of the list, actually in this list, there are 20 products. We can see the difference is less than 0.8. So like 0.8 looks like a small figure, but when it comes to the solar industry, it's really a huge improvement and a huge development in the solar industry. Also, one of the best features we have in our products, the partial shading optimization. And I would like to show you in this video one experiment we have done in our headquarters in China. So on the left side, you can see our module, and on the right side, you can see a traditional module. Actually, it's a TOPCon one, but can be also a PERC technology module. And what we do, we connect both modules with the voltmeter to show the voltage output, and also we connect them with the water pump. And you can see here the height of the water to express the power output of the module. And what we start doing, we apply shadings. And after applying the first shading, you can see a significant drop in the traditional module. And we continue doing the same by shading more cells. And you can see the effect happens on the power output for the two products. Yeah, applying just more shading. And finally, we completely covered the two middle rows of the half cells in the middle. And after doing this, our module is still providing 65% of its rated power, while the traditional one is completely gone. Related to that, also we requested TÜV Nord to test this feature, and the report we got from them showed that we can generate 30% more electricity compared to TOPCon by shading one cell. And the question is normally how we can do this, like AIKO, how we could manage to do the partial shading optimization. And in this video, we can see an illustration for that. So two things. First, we managed to do this on the cell level, as you can see. So when one cell is shaded, you basically just lose that cell, but you can still utilize the rest of cells in that string. And for the traditional modules, they do the shading optimization on the bypass diode. And to understand how we do this, so the semiconductor material, the silicon cell, when it gets shaded, it will form something called a breakdown voltage. And this breakdown voltage in the traditional cell has a value between 10 and 15 volt. And this will let the cell to act like a resistance in that string. And by time, it will be heating, and it will be like a hot spot. And in order to prevent the cell damage, or in the worst case scenario, the whole module could catch a fire, the bypass diode will kick in and will save the module. But by doing this, you basically lose one-third of the module. And also you can imagine the effect you have on the rest of the modules on that string, and which will cause a drop in on the performance of that specific MPP connected to the inverter. So what we have done, we developed the cell structure, because we came from, this is our background, we came from the solar cell manufacturing, and we thought about solving the shading issue on the cell level. And we developed the cell structure itself to have what we call soft breakdown voltage. And instead of like 10 to 15, we have maximum 5 voltage. And this will let our cell to act like a bypass diode. So physically there's no bypass diode, but the cell itself will act like a bypass diode, and the flow of the current, the electrons, will bypass the shaded cell, and it will keep moving. And you basically just lose the performance or the output of that specific shaded cell. Another also features the high temperature restriction. Also, we do another experience here, and we shade one cell from our module and one cell from the traditional cell for 1 hour, and we check the temperature. And for the traditional module, it's 147 degrees. And our module, after 1 hour shading, is 100 Celsius. So this also will reduce the potential of having a fire hazard. This is really something good for the end user to have a safe solar product to save in the first place the solar system and also his property as well. Another feature is the micro crack resistance, and maybe we need to understand first what's the micro crack. So those micro cracks, normally it's like a very small tiny crack could happen on the cell body, the cell structure, and if it happens, actually it will block the current collection. The flow of current will not reach the bus bars, which is the metallization I mentioned before. And this could happen during the installation, if you apply pressure on the module, or even during the shipment of the modules. Could happen also due to the snow load, if you have snow on your modules. Due also to the temperature difference between summer and winter. And many studies nowadays in the market shows that many panels in the market has the micro crack issues. And not normally the potential spot to have a micro crack is at the edge of the cell, when the welding line going from the top side to the downside. So in the traditional module, normally the soldering, the welding happens from top side to the downside between the cells, the row of the cells. And since our module is based on the back contact technology, we do the welding only from the back side, and this will reduce the potential of having micro cracks. Also, our welding strength is 3 times than the traditional one, because we use copper alloys. Our module is silver free. We don't have silver in our modules, and copper has more strength. And also we have 20 bus bars in each cell. So, and if you look to the industry, you will find between 12 and 16. and by increasing the bus bars, even though if there's a potential of micro cracks, the chances to catch electrons is higher, and this will have a better impact on the yield of the solar system and on the financial as well. Another also features the better temperature coefficient. So our figure is 0.26 percentage per Celsius. And maybe we need to know what does it mean, the temperature coefficient. So normally what we see on the panels, like 420 watt panels, this is the nameplate power, which they give to the panel at the standard test condition at 25 Celsius. And in reality, when the solar product is operating, the temperature of the panel will be increasing. It can easily reach 50 or 60, maybe in Sweden, maximum 60 in the summertime, but it could reach like in the southern part of Europe, it could reach 80 Celsius. And each Celsius above 25 degrees, it will affect the power by this reduction. So the power will be reduced by this value, the 0.26. And if this actually has a major impact on the performance of the solar system. So if you just look to the 60 Celsius, our module will perform 1.4% better than the top one ones. And we asked Clean Energy Association to test our modules regarding the temperature coefficient, and we got 107 out of 100. And the story behind this extreme score that before they test our module, they tested 30 modules in the market, and they gave 100 score for the temperature coefficient with 0.29. And then we came later with this value, and we got 107. Bifaciality rate, we have a bifaciality rate of 70% for our stellar module for the utility scale. I know in the market we can find 80 and even 85% bifaciality rates. But if you just look to the modules based on the back contact technology, we are the only one who can achieve bifaciality rate, because what we have done, we put all the metallization from the backside. So we almost blocked all the area, the body of the cell. So it's very hard to get reflection from the sunlight. Actually, our first generation doesn't have any bifaciality, but in the second generation of our module, which is now available in the market, we managed the circuit of the metallization from the backside, and also we reduced the doping of the silicon wafer in order to get some sunlight from the backside. Yeah, I would like also to share you some scenario analysis. One for the residential market and one for the C&I. So normally when it comes to the residential scenario, we know that you are facing some challenges, like first one, the architectural aesthetics. The clients, they would like to have pretty and good looking panels. And we have the black ones, which is really suitable for their needs. Also, the limited roof areas. Normally for the house, for the houses, you find chimneys, skylights, some trees. I'm not sure, like in the Middle East, we have a lot of outdoor ventilation units because it's really hot there. Maybe in Sweden, you don't need them, but this is the case in the Middle East. And also the shading due to bird drops, trees, chimneys, as I have said. Also, they are afraid from the fire hazard. So with our products, we try to optimize all these challenges and try to overcome them. And as I said, we promote our modules, which is less than 2 meters normally for the residential scenario, the new Star series. And this might be interesting for you. It shows a case study. It's a typical household project, and we do a comparison between our product and the traditional product in the market, which is Topcon in this case. This is PERC. So we provide the same number of panels. It's 14 panels for each option. And due to the high power we can achieve with our panels, you can push the power output of the solar project or the DC capacity up to 10% more than the traditional option. And this extra investment you do in our panels, you can get it really very fast. So the payoff time of our module or the extra investment is just 2.3 years. And this extra power output of our solution will increase the lifetime production of the project to more than 16%. And this will also have a good impact on the financial benefits of the project. It will deliver 10%. Actually, I will be later showing you case studies based on the Sweden market, one residential, one C&I. It also shows the same concept and the same benefits of the customer. When it comes to the C&I scenario, also we see some challenges like limited area, and with our modules you can achieve normally a higher power output, as I mentioned. It's basically the same idea and benefits of a residential scenario, but like in the C&I, it's even more. When it comes to also C&I, some products, they have high BOS cost. BOS stands for balance of system, the mounting systems, the racks, the cable trays, the cables you have, or the inverters as well. So you can reduce the BOS cost, because basically you provide the same number of panels and you increase the DC capacity of your system, but you still have the same balance of system. And also we see the shading issue as a big challenge for the C&I. And due our partial shading optimization, we can reduce this challenge. And lastly, the operation and maintenance. Due to our feature, the high temperature restriction and the micro cracks, the cost or the operation and maintenance cost will be reduced. And also something I would like to highlight, which is related to the partial shading optimization. Normally, when the traditional module is shaded, the bypass diode will kick in. And the bypass diode is really a crucial part of the modules. And many modules, they get changed after like 7 or 10 years due to the bypass diode issues, because they have an issue and then you need to replace them. And due to our feature, the partial shading optimization, the bypass diode will be less activated and it will be aging less. So this also has a good impact in reducing the operation and maintenance. And also another study typical to the residential one shows that we provide or we install the same number of panels. And here you can see the extra power output you can get with our solution that will lead for more lifetime production, like more time. It can provide more yield and more energy by time, and also will bring more money to the end user. So basically, this is the presentation I would like to share with you. Thank you very much. And yeah, if you don't have at the moment any question, maybe I can jump to show you the leaflets I have prepared for the Sweden market, or we can do it later. It's up to you. Just let me know if you have any question.
And you're just free to unmute if you have any questions now, and just shout out or write them in the chat, whatever you feel like. I can say when me and Mohammed had our walkthrough of this presentation 2 weeks ago, we discussed a lot of things, and there are a lot of things that are to be discussed and hard to understand. I think especially the shading optimization is really interesting from AIKO side. So, but unless anyone has any questions, Mohammed, please go ahead with the
Sorry,
Yeah.
I have one question, if possible.
Yeah, please go ahead.
So, given the increased shading performance or anti-shading performance, would you say that your products they don't need, say, optimization from, you could say, Solar Edge or Huawei, or if there's a shading condition?
Yeah, actually, it's a very good question. In reality, we do different level of optimization. So it's a different optimization. So what we do, we optimize. We do the optimization on the cell level. So it means if one cell is shaded, you lose that cell, but the rest of the cells will keep it producing. But let's say one cell is shaded, and in our scenario, the rest of the modules connected to that string will be also reduced by this drop. And what happens in the optimizer, basically, let's say one cell is shaded in the top corner perk, you will lose 1/3 of the module. So you lose more out of that module, but the optimizer will change the voltage of that panel, and actually it will reduce it, and it will increase the current to not affect the performance of the rest connected cells, connected modules to that string. So I believe that the optimum scenario to have two things at the same time, like if you have the optimizers plus our panels, you can achieve the best performance of the solar system. And something like I would say it's actually a negative point for optimizers, that it's really costly, because you will invest more in at the capex at the initial of the project, and also they need to be replaced after maybe 5 years, let's say 7 years. And it's not only about the money you need to invest in the optimizers. Let's think about like sending 1 or 2 guys to make the disassembly of the modules and change the optimizer. It's yeah, I don't know how much it will cost in Sweden, but I think at least 200, 300 euros, maybe more, to change an optimizer. So it's really costly at the capex and also at the opex time when you do the maintenance.
Thank you.
Yeah, you're welcome.
Okay, we just got a message in the chat to see the leaflet, so I think they're excited.
Yeah, I would like to send it to you guys, or I can send it with to you, Boron, and you can Juron, and then you can share it.
I will upload them to our SharePoint and then send it to all participants.
Yeah.
Able to go.
So basically, our leaflet or one-pager document, it's like one leaflet has the two faces. On the first one, you can see the product warranty. Something I maybe missed to mention, that we provided 25 years warranty for the full black modules, which is, I think, the most requested product in the Sweden market. So 25 years for the product warranty and 30 years for the performance warranty. So you can see on the first page the unique selling points or the features I have mentioned. Like you can get the highest module power, like a comparison between our module and the Topcon one. And then the advantage you get due to the partial shading optimization, you can get like 30% more energy. And also the pure black aesthetics, where we don't have any grid lines at the front side, no bus bars, no fingers anymore. We put everything from the back side. This will give the module good looking and good appearance. It's like a pure black. And also the high rooftop safety, because we reduced the temperature in case of like shading and hotspot. The temperature of our module will be just 100 Celsius, and the traditional one could reach 150. And something similar to the case study I have explained on the second page, like a typical household. So I did this study for Gothenburg in Sweden. It's like four people household, and they have this much as an annual electricity demand. And there's also some description on the project, like it's a tilted roof with this with this angle, and it's south oriented solar project. And this is the electricity prices. This shows the average price. I know you have a spot scheme, the price is changing, but like this is the average price during the year, and considering also all the taxes you need to pay. So this is some like background, the story behind this project. And then this is some output information you can also share to the end user, that with our solution, with AIKO, you can get annually this much, 14% more electricity. And this also will reduce the payback time of the project to 10 months less, or 10 months faster, the payback time of the project. And this also will give you this much extra benefits in terms of money. And also we think it's good to show them like you will get this much as a free or extra energy compared to the traditional solution, which is equivalent to like 1.5 months of electricity consumption. And you will be saving this much of CO2, which is equivalent to this distance driving by car. Honestly speaking, I used the European here CO2 savings, because I know Sweden is very efficient in terms of CO2. You have a lot of hydropower and I think renewable energy sources. And I consider like Sweden is part of the EU, and then you are participating to reduce the CO2 of the European region. And then at the end also, here you can see the comparison. So 28 panels for each scenario, and you will get this much of energy. Actually, it's coming from these reasons. You get this much extra energy. And this shows the system cost. Like it's very small extra investment at the beginning of the project, but it will bring a huge benefit to the customer. It will increase his financial benefits. So this is the second page, and the first page for the residential scenario. And I need to jump to the.
While you're jumping, we got some questions here. I think it could be nice to just have them on the side.
Yeah, please.
First, regarding the this slide, it's 1.627 means 1627 kilowatt hours, right? If you scroll down. If you
1627.
if you scroll down on the production increase on the second part of this page.
Okay. You mean this one?
Yeah, 1,627 kilowatt hours.
Yeah, exactly. So it's the extra energy you can get annually out of our system compared to the traditional. Like normally, if you compare our solution to PERC technology, the difference will be bigger because PERC is, let's say, has a maximum limit of efficiency around maybe 22 or 21.5. TOPCon has a better performance in terms of efficiency. So the difference with TOPCon will be a bit less, but it's still a good chance for the end user to make the best benefit out of the solar system, to go with the most efficient modules in the market.
Yes. And then some other questions. So first, regarding the fire class of the dual glass panel, do you know what fire class it has?
So we actually do 2 tests for all our panels. One according to the Italy fire tests, and normally I think we got class A or the highest one. I don't know if they give it like A, B, C or class 1, 2, 3, but we got the best performance according to the Italy test. And according to the IEC, I think it's a class 3. And the reason behind this that the standard or the requirements of the IEC just to do the test and pass class 3. So basically, or I would like to normally to share the 2 documents, the 2 certificates with our customers to show them that we have class A according to the Italy and class 3 according to the IEC.
Okay. And then you had a question about you were at Elmia and you showed your panels there, and then you showed a thin plastic panel at Elmia. Do you have any information regarding that panel?
So you're talking about the light module, the air module. Yeah, actually, I can maybe let me stop sharing first to find the data sheet. Do you think showing you the data sheet will be interesting, just to show you some features of this product? Because what I know, it's a very light product. Its weight is just 9 kilograms. The delivery time will be an end of July, I think. I can cross-check this info. And yeah, I think it's suitable to be installed normally on the like facade or on the roofs where you cannot apply a huge load of the solar system. Let me know if maybe later I can also send you the data sheet. You can send it to them.
Yeah.
But if you have a specific like question regarding this product, yeah, please let me know.
Otherwise, we'll send it with all the other documents.
Yeah, and also I can send the installation manual for like the data sheet, the installation manual, and you can go through them, and it will give you also more information about the layers we have used to build this product. What are the material there?
Yes. Thank you. And then another question regarding the bypass diode. So when you have this shading optimization, how many cells need to be shaded before the bypass diode kicks in?
Good question, actually.
Yep.
So according to my understanding, because I never did the test by myself, like to see when it will be kicking in. if you reach the same level of the breakdown voltage like the traditional one. So what we have done, we optimized the cell structure to reduce the breakdown voltage and have softer breakdown voltage. So the current will, will flee, will bypass the cell. But if you shed, I would say 3 or maybe 4 cells in row, maybe then you form the same breakdown voltage, and then the bypass diode will kick in to to save the cell not to be very heated, because normally the worst thing you can do to the solar cell to heat it up, because heating it will accelerate the degradation and might damaging the cell, might damaging the soldering, the welding, might, in the worst case scenario, the module could catch fire. So I would say if you shed four cells in series, the bypass diode will kick in.
Yes. Very good question.
Yeah, it is.
Yes. Okay. And then we have a question regarding the shipment schedule for delivery in Sweden. Maybe that's a question for us, which I'm not exactly sure of.
So,
but we are available. Yeah.
Yeah, what I know that you have ordered several containers, and I think they are already in stock.
Yeah.
So it depends like how many days it will be going out from, like, I don't know how many warehouses you have, like 1 or 2 in Sweden. Depends on the location, but I think you can do it with 1 week. This is a reasonable, or even less. I don't know.
And we have in stock now, so that's good. But there might be more incoming for that later.
Yeah, we hope so.
Yeah.
And guys, if you have like any specific project, especially on the C&I level, like normally you might have 1 meg or 500 kilowatt peak, or even like in Germany and in Netherlands, we did 5 mega on the roof. I would like actually to help you on that specific project on that level, to show this kind of analysis, this study to the end user, and try to show him the values, the benefits he can get with our modules. So we are happy to cooperate also on that level to make a specific case study for a specific project.
Yes. Okay, those were the questions. And if you guys want to show shortly the other leaflet on...
Yeah, it's actually the same, like it's similar to the residential scenario. Basically, we try to use the same approach. So this is the power you can get, and also the features, unique selling points. So instead of the aesthetic, the pure black, we showed here the degradation, which is like one of the reasons that our product can generate more energy also by time. So the efficiency, and also the degradation of our module is less than other technologies. And also, sorry, on the second page, yeah, typical case study, showing also the details of the project. And this is the system size. So it's beneath the limit, the 500 kilowatt peak, to not consider your project as a small generation plant, and then you need to pay the fees, or basically let the customer pay the fees. And this is the additional electricity you can get. The payback time will be 1 year faster with our product. It will bring this much extra energy, which is equivalent to this much as a money.
Okay. Thank you very much. We will upload this after the presentation, and we'll send them tomorrow or today.
Yeah.
Also with some more info and also the recording of this presentation. So, unless anyone else has any questions, now is your last possibility for now to call out. I will give a warm thank you to Mohammed and AIKO. Very nice to have you here.
Thank you all, guys.
Yeah. And I'll let you know about the upcoming sessions with AIKO later as well.